Hi, I'm Omar Zeb, and in this video, I'll be talking about consensus algorithms. Consensus algorithms are used to gain agreement between networks of nodes in distributed system. A consensus algorithm must have these three following properties. Agreement, where every correct process must agree on the same value. Validity, the value agreed on must have been proposed by another process. In termination, a value will eventually be decided by every correct process. Another important theorem for consensus algorithm is the gap theorem. An algorithm cannot provide more than two of the three following properties: consistency, availability, and partition tolerance. There are different types of failures that a consensus algorithm might have to deal with: fail stop, network partition, fail recover, and Byzantine failure. Byzantine failure got its name from a computer science paper written in the 18th where the Byzantine generalist problem is described. The problem describes 9 Byzantine generals who surrounded a city and then can only take the city if they attack at the same time. The generals can only communicate by sending flaky messengers who can get lost or caught. It's not known if one or more generals are traitors and will send messages to sabotage the loyal generals. There are many different consensus algorithms, but I will focus on the one called Raft. Raft stands for replicated and fault tolerance. Raft does not use time, it uses terms instead. A term is an integer that starts at 0 and increments by every time one election is held. Each term starts with an election represented by the red color. The time for the leader election should be a short fraction of the entire term. A node in the cluster can be in one of three states: followers, candidate, or leader. All of the nodes in the cluster start as identical followers that all have the potential to become a leader. Each follower has a random election timeout. To start an election, a follower times out, vote for itself, and send out a vote request to the other followers. When a follower receives a vote request, it will increment its term. It will vote yes if has not voted in the current term. Once a candidate has received the majority of the votes, it will become the leader. The leader will send out the heartbeats to the rest of the followers' election timeout. These heartbeats come in intervals decided by the heartbeat timeout of the leader. The leader can also send append entries message to the followers. These will also count as heartbeats and reset the election timeouts. Now let's imagine that a leader dies. A follower will not receive any heartbeats and therefore its election will time out. It will become a candidate and vote for itself and request votes from the other followers. The leader is only server that can accept data from the client. Followers will simply redirect to the lost leader they heard from. To commit something to the log, the leader proposes append entries to the followers, and once the majority of the follower has responded, the leader sends out a commit message. Once the value is on the majority of the servers, it is considered committed. This allows the system to tolerate a minority failing because there will always be an overlap in the majority. Thank you. I hope you understand the concept of gap theorem.